Hello, students. Had a couple more questions out of 11B, 11-1B. So we're going to start off with question number 4. And this one's talking about how many planes can be determined by a certain number of points. And so just remember a couple key pieces. Let me get a little bit of white space in here. I guess up here too. And we'll get rid of that too. Okay, just so we can kind of concentrate. Okay, so here's the idea. When we had 2 points, any 2 points, we could always make a line between those 2 points, right? So 2 points, I can make one line. Now, if I want to make more lines than that, I have to make sure that I don't choose a point that's already on the line. Because if I choose a point that's on the line, I didn't create any new lines. As a matter of fact, if this was A and this was B, and I just put point C right here in the middle, then line AC is the same as line BC, is the same as line AB. So I didn't change anything. So this is where we got the idea of being very careful. We want points that are non-collinear. Okay. Okay, so now what would that look like? Well, now let me go ahead and erase these. Oops. I erased a little tiny bit too much. How can I just want that. There we go. Okay. So let's go back and say, okay, so here's our line. Here's our line in red. So I need a point that's not collinear. It means it's not on the same line as A and B. So I pick another point down here and I call that C. Now I do create additional lines. Now line AC is different than line BC, and it's also different than AB. Okay, so that's why I needed 3 points that are non-collinear. So how many planes can be determined by this? Well, if you just have 3 points and they're not collinear, those would be the 3 points that are sitting kind of on the surface right here. Okay, so if you want to think about this, take any 2 points, right? Take a pencil or a pen or something like that in your mind, kind of say, okay, so it's between those. There they are. Now pick any other point in space, anywhere that's just not on that line, and you can kind of picture a plane that cuts through this line, because the line, kind of think of it tipping and rotating, and then it just tip it until it goes through that point. Boom, that's one plane. So how many planes are determined by 3 non-collinear points? One, exactly one. This is a very, what we would say is analogous, which means it's just like 2 points. Between any 2 points, how many lines are there? There's one. Between any 3 non-collinear points, there's one plane, and exactly one. Okay, so be careful with this. So this would be the kind of thing like always, sometimes, never. This would be a big always, sometimes, never question. And how come? Well, because when you think about it, I would say one plane, one unique plane can be determined by any 3 points. Okay. So that's a great always, sometimes, never question, right? Is that always the case? Is it just sometimes the case? Or is it never the case? And so if you think about any 3 points, but take a look, we're missing one key word here. If I had added non-collinear, then you would say always. Because I didn't add non-collinear, you'd have to say sometimes. Because if it's collinear, like the 3 points are all the same, then one unique plane cannot be determined. There could be infinitely many planes. Okay. But if there are 3 non-collinear points, then it's exactly one. So there's the sometimes type of piece. All right. So there we go. Let's get back to it. Now, how many planes can be determined by 4 points that are not coplanar? Okay, so it sometimes helps to think about things that are like what you might already picture in everyday life. So if you want to picture something like a Rubik's Cube, again, it might help. Okay, so I'm going to draw a Rubik's Cube here, basically a 3-dimensional cube. Okay, I'll put some dotted lines there to kind of help. Okay, so there's a 3-dimensional cube. So now let's talk about some points. Okay, I'm going to go to the back surface because I have a point here and I have a point here, and I have a point down here. Those are non-collinear. So I know there is a plane that is made with the very, very back surface. Okay. And I'm going to try to do, how can I do this? Ooh, I think I can do it with shading. Let me try it. Highlighter. I'm trying it with the highlighter tool. Oh, look at that. Oh, that's very nice. Yes, very, very nice. Oh, yeah. Is that? I have no idea. I hope that it's coming through clearly to you. Honestly, it looks like it's getting a little sketchy to me. Okay, there we go. Good enough. All right, so there we go. So this is a plane. So that is a plane, right? Now, what I need to do is I need to pick another point. So I need to pick a point that is not on that plane. And do remember that plane goes on indefinitely, forever and ever and ever. So I'm going to pick a point right up. Where do I want to pick a point? Pick a point maybe down here. Oops, I got to go back to the other non-shaded one. I'm going to pick a point here. Okay, there we go. All right, so now how many planes can be determined? Okay, so we know this is 4 points. We saw 3 points. We kind of know what that looks like. So now what I need to do is I need to take these points and kind of think of a plane, because remember, any 3 non-collinear points forms one plane. So if I call this A, B, C, and D, there it is, right? So then I know my planes are, I have A, then B, then C. Perfect. But then I also have A, then B, then D, right? A, then B, then D. Now, I'm going to do my best to shade this one for you so that you can kind of see it. I think I'm going to try to use blue. Here's what that one looks like, A, then B, then D. The plane comes down like this, okay, right there, and is kind of this diagonal. If you think of it like cutting through a block of cheese, it's going to make that kind of wedge. That would be the plane here. So if I look here and see this plane that goes through the middle of the block, that's the plane that I'm referring to with ABD. Okay, kind of that slanted one. Okay, so that's another plane. It's totally different than the first plane. They do intersect, right? They do intersect. They intersect at the line AB because that's what they share in common. That would be the two planes intersecting at a line. Okay, any 2 planes intersect at a line. Okay, so there we go. So let's get rid of that one just so we can kind of say, okay, so we see that one. There's ABD. Okay. Now, again, all I'm doing, if you think about this, all I'm really doing is I'm just naming the plane by taking any 3 letters. And it just can't be any 3 letters I've already done. And I can't reuse the 3 letters in any order. For example, I can't do CBA because that plane is the one that's in red. I already have shaded back here. So I can't do that. Okay. So I have A, then B, then C. That's perfect. A, then B, then D. That looks good. And then let's see here. What else could I do? I've started everything with A, then B, then this, A, then B, then that. Oh, let me do an A, then C. Okay. What about A, then C, then D? Okay. Right? Because I did everything I could that started with an A and a B. I picked a C and I picked a D. Got it. Then I go everything that starts with an A and a C. Okay, A, C, D. Oh, now this one is a little different. Again, it helps to visualize. Take a look, go A to C and include D. And so this plane right here is going to cut across, but it's cutting in a different direction. Okay, so it's kind of slanted going this way. So again, looks like kind of a block of cheese, but it's cutting through the front face of the cube this time. Okay, A, then C, then D. Okay, so we have that one. And now let's go for anything else. So I've done everything that starts with A, then B, did all those. Everything that includes an A and a C, okay, because I already had A, B, C, and now I have A, C, D. Okay, got that. And then what else do I have here? I have to have, well, I guess I've used everything that starts with an A. Let's just go now to B, then C, then D. B, C, D. Oh, okay. This one might be easier to spot because B, C, D, if you connect those points, it turns out that it's just this side face. right here. So this one would actually be on the cube. This one doesn't cut the cube apart. It's right there. So for planes that are non-coplanar, there would be 4. Okay. Cool. There's 4. So 3 points makes 1 plane. 4 points makes 4 planes. So now if I added another one, making very clear, and this is the key distinction here. This is why it's so important. It says no 4 of which are coplanar. So if you're kind of asking yourself, why is that important? What's the big deal, Scott? Well, think about it. If this goes back to the same type of thing, if I put another point right here in the middle of this line, it's like, yeah, I still make a little bit, like there's a little tiny bit of a newness, but not as many newnesses, if you will, as if I had put my line or my point down here. Here I could have D to C, I could have D to A, and I could have D to B. That would be much different. If I added it on the line, I'd only add 1. So that's why we're actually putting these conditions on. So why are they saying no 4 of which are coplanar? Just realize you've created a bunch of planes. We already had those planes. Don't put your new plane on one that already exists. Don't put your new line on a plane that you've already got. Does that make sense? So now let's take a look. So A, B, C, you can see those in the back face. If I made my 4th point in the back corner, then plane A, B, E would be the same plane as ABC, which would be the same plane as BCE, because all I do is grab 3 of the points that are on that plane and it names it. So don't do that. Okay. And we got to be kind of careful here because now I can't pick one that's on a plane that I've already created. So think about those, the one that cut through. If I put another point up here, right? That point, maybe even inadvertently, falls on the plane A, B, D, the one we already named because it's one other corner point there. So we cannot choose that point. Okay. I cannot choose the one that comes across, what did we say here? A, then C, then D. Okay, so I can't pick a point up here. All right. I also can't pick a point on this side one. So what it means, I can't pick one of the other points on a cube, or at least at the points of a cube. But I could pick a point down here somewhere as long as it's not on one of those. So if I want to pick point E, I could pick point E. And now I create a whole bunch of new planes. Okay, so I have point A, B, C, D, and then point E kind of floating halfway down on this cube. And I'm only using the cube to help you kind of see where these could be. They don't have to be on the cube. You could pick something that's not on the cube. You just need to make sure it's not on one of the other planes. Okay, so yeah, then I could have A, then E, then B. And where would this go? So now this is a kind of a weird slicing plane that slices through, doesn't go all the way down, but kind of cuts through in the same way that ABD cut through. So I could have AEB. I could have AEC. Oh yeah, that plane, that one would cut through. That's a nice plane right here, cuts through the middle of the cube like this, going up at an angle. That's a brand new plane. So then as you look at those and you say, okay, let's see if we can make a pattern, because as we know, math is the science and study of patterns. We could say, well, let's go do this. Let's find all of the planes that we could make with those now 5 points. So let's just see here, those 3 points, we know we make 1, right? For 4 points, we already did that. 1, 2, 3, 4 planes, okay? So now we're going to do 5 points. Okay, so let's kind of see. Now remember, I still get all of the planes I had before. Like these don't go away. It's like, woohoo, those are pretty quick. Okay, so I already get those. So now I have to think about what else could I have done. So what am I missing? I have ABC, I have ABD, I need ABE. So I'm just going to add that one in, ABE. That's a new one. Okay, what else do I need to bring in? Well, I need to bring in ACD, already have it. And I need then A with C with E. I don't have that one because I didn't have point E before. Okay. So now, once again, I've covered all of the potential it looks like with one additional piece. I could have another one with A. So this is all the ABs, there's 3 of them. All the ACs, there's 2 of them. And all the A's by itself, which would be A, then D, E. So A, D, E. Okay, so that's all the A's. Now let's go to the B's. The B's, I have B, C, D. That's great. I have B, C, E. That's fantastic. And then lastly, I have C, D, E. Okay, so I've added 1, 2, 3, 4, 5 to this. Let me make sure I didn't miss any. A with B, so keep the A, the B the same. A, B, then C, then D, then E. Okay. Then A with C, and I go, so C with D, C with E. That works good. And then A, then D, then E. That looks good. B, then C. So B, I did miss one. I did. Take a look. I did BC, and I did BCD, and then I did BCE. But before jumping to CDE, I should have said, what else can I do with B? I could have done B with D and E. All right, let's take a look. So I have 1, 2, 3, 4, 5, 6 that have A in it. And then B, C, D, B, C, E, 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10. Okay. I have 10. That is pretty cool. All right. So there we go. Let's see here. Now, it might be helpful to make kind of a nice little pattern out of this. I mean, it's up to you, but for me, I was like making patterns. And so there are a couple patterns we could see, some of which came from things in Math 105, and others come from new pieces. So let's take a look. Okay. So why is this so important and also so cool? So if I look here and I say, we'll start with ABC. Okay. There's only one. So that's the 3 points. There's only one, ABC. Okay. Next one, I have A with B with C, then A with B with D, right? And I finish off all the A's with these, and then I have A with C with D. Okay. And then I have B with C, right? Then I have what? B with D, right? And then I have C with D. Okay. Oh, I don't know why. What? I was doing all the line segments. Then I have B with C with D. There we go. Okay. So that's our 4. So where we have 3 points, we have this one. Where we have 4 points, we get 4. Where I have a 5th point, I have all of these that I had before. That's the 4 I had, right? And then let's take a look and see what we add to it. Let's see here, BC. So I have ABC, ABD, ABE. I'm going to put all the ABs together, right? And then I have all the ACs. So A with C with D, A with C with E, and finally A with D with E. All right. So there we go. That's fantastic. That's all the ones with the A's in them. Then we go down to the B's and we'll repeat. So now I use B. I have B with C with D. I have B with C with E. I have B with D with E. And then lastly, I have C with D with E. So I want to show kind of something that I think is really, really cool. And I hope that you see this pattern coming. I'm going to show it by going with red to kind of show what happened before. So what happened before was right here. All right. That's cool. And then I'm going to bring the ACD. You know what? I want to bring that ACD down. So, God, what's going to be my best way to do that? Can't erase on the white stuff, so I'm just going to bring my ACD down. There we go. Okay, I'm going to write it underneath ACD. Okay, and the reason is, what I want you to see is this. What I have with A's is I have a beautiful kind of stair-stepping pattern of 1 plus 2. I get down to the B's and I get a new pattern, but that pattern just has 1 in it, just like we had from before, just the 1. Let's take a look at the next pattern. Okay, the next pattern we see, if I write it in this way, has a 1 plus 2 plus 3. Well, we know 1 plus 2 plus 3 is 6, which is also 1 plus 2 plus 3, right? And then take a look at the next one down. Next one down is what? Because it's like we're going back, basically from this point, it brings back what we had before, right? And so we say, okay, well, I have everything I had before, which is a single and then a 1 plus 2. So I have a 1 plus 2 and I have a 1. Okay. So I start with a 1. The next one is a 1, and I added on a 1 plus 2. The next one is a 1 and a 1 plus 2, and I added on a 1 plus 2 plus 3. And so you get this kind of really nice pattern that continues in this way. So to determine by n points, we would just continue along this way. Now, this was for 5 points. So 5 points could have been written as 1 plus 1 plus 2 plus 1 plus 2 plus 3. There it is. That's for 5 points. Okay. And then for 6 points, I mean, I hope you're seeing this because this, to me, this is like super cool. I hope you like it as well. So for 6 points, I'd have 1 plus 1 plus 2 plus 1 plus 2 plus 3. So I have everything that I had before. And the next one's going to be plus 1 plus 2 plus 3 plus 4. Okay. So really what I'm doing every time I add another point is I'm adding another row. I'd add like another row up here to the top. I'd add another row to this. I'd add another row to this. And then I'd add a starting one here, which means I'm going to have that same kind of sequence going. Okay. So there we are. So that's how we can determine how many are in a plane. So this is for 6 points. I can go down and find this 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus 1 plus 2 plus 3 4. And I get these kind of sums of sums, if you want to think of it that way. So that is kind of a nice way to do it. Is there a quicker way? Yes. Let's see here. Let me think of how. So if we did one of those patterns, let me erase all of these here. Clear all those drawings. Oh, yeah. So there actually is a way of doing this that is a little bit quicker, and it comes from kind of a nice connection with geometry and with Pascal's triangle. So what you'll get to see is all the different ways that you could choose the lines. Well, they actually all come right down here. This was doing the lines, 1, then 3, then 6, then and so forth. We're doing planes. So planes, we actually just move 1 down, and we'd have this beautiful pattern right here. So with 3 of them, we'd get 1. With 4 of them would be here. With 5 would be here. With 6 would be here. With 7 would be here. Okay. Now notice it has to start on a certain level. It can't start up because what would you do with 2 points? It doesn't exist. Okay. So this is 0 points, 1 points, 2 points, and this is for 3 points. We're going down this way. So there you go. So that is a different way of kind of finding them. But each time you'll see that you're actually just adding the same thing that we would have had before. So I guess that's what's kind of cool about these these patterns. So yeah, as you're looking at them here, you would get, so to get to the next one, I'd add 10, right? So if I had 4, the next one adds 6 and I get 10. The next one adds 10, I get 20. The next one I'd add 15, I'd get 35. And so we get this kind of zigzag pattern, if you will, by just thinking of how many different ways could I combine those new ones. And the next one coming down would be 56. And so that's kind of that's the idea here. So visually, is there a formula? Yes, there is, but it would say it would exceed the scope of this course. So I'm not going to go there, but I do want you to see the pattern because I think the pattern's more important than the formula. Okay. All right, let's take a look. What else do we have? So there's 4, B, and C. Okay, number 7 was up next. Coplanar points are such that no 3 are collinear. That makes sense. Explain how many distinct angles less than 100 degrees they determine. So we cannot choose, let's see here. Let's get some white space. 4 points, coplanar points, are such that no 3 are collinear. Okay, so that's important to know. So what does that mean for us? It means I need to be able to select points that are not collinear. And of course, any 2 of them will be collinear. So let's just start making them. So here's A, here's B, okay? Now I need point C. I just can't put it on the line between A and B, okay? So I'll put point C down here. And then again, think of all the lines this could create. Pick point D so it's not on any of those, okay? So why don't I pick point D up here? Okay, so how many distinct angles less than 180 degrees can I make? Well, there's one angle I could make, right? There's a second angle I could make. Let's see here. I'll choose a different color. Here's a third. Okay. And then up here, right down here, this would be a fourth angle, right? Total. I'll make this one kind of fatty. There we go. 4. 1, 2, 3, 4. And if I go up, right? Then here's another one. 5 up here on top would be 6. So 1, 2, 3, 4, 5. That's 6 of them so far. And then don't forget, I could also come down this way with a line to make another angle up here. So as a 6, this would be 7, 8, 9, and 10. And then I also have this angle right here, which is the whole thing. That would be 11. And that right there would be 12. So those are all the angles that I've determined that are less than 180 degrees. Okay. Let's see here. So these are how many distinct angles less than 180 degrees. Now this depends on you, I guess, because we really could extend this line out and create an angle out here that would be less than 180 degrees. But in order to name it, I could not name it using the letters. This is like what happened in class where we had that line segment. We had like A, B, and C, and I asked you to form all the rays. And we'd have a ray from A going this way and B going this way, but we really don't have a ray from C going this way. It exists, we just can't name it. And so that's why we're like, which ones can we name? The only one I can name is A to C and B to C. So I would probably leave this one off of my final answer, even though it is created. How many distinct angles do they create can be determined. So that would be something else. And again, you can do the same thing then right over here and say, well, this is a different angle right there. And we'll see that actually, even though it's a different angle, the measure of the 2 that I just drew in orange, we'll see that in the next section. They turn out to be exactly the same. Okay. So there we go. So hopefully that helps, gives you a little guidance there. And 9F. Let's take a look at 9. Oops, I got to change pages. 9F. A plane not determined by one of the 4 triangular faces. Okay, so we have 4 triangular faces. This is technically called a tetra for 4, tetrahedron, meaning 4 heads or 4 faces. And we can kind of see the 4 faces. That would be A, B, C, A, B, D, A, C, D, and then B, C, D. Those are the 4. Now they did put a 4th point down here. So similar to that first question we had, just put another point. Now notice that point E is on plane ACD. It is located on ACD. But if I want a plane that's not determined by one of those 4 triangular faces, I could create a plane that goes and uses E and cuts through the middle here. So I could create plane B, E, D. Okay. And you could use others. You could use like ABE or CBE. Those would all be planes that are not using one of the 4 triangular faces. Okay, so there you go. There's one of them. BED. Again, I would also take a BE or a CBE. And I guess you could have called this DBE if you wanted to be consistent. So take BE and pick any of those other ones. Now, if you didn't pick B, notice all of three of these have B, and that's because B is the only point that's not on that plane right now. So we have to use B as we're determining a new plane, because we don't want it to be one of the triangular faces. So if I pick, C, D, and E, that's going to be the bottom one. A, E, and D, that's the bottom one again. So that's why all of those happen to have B included. Let me check back on the email, and there it is. That's it. So that does it. Hope that helps. Off you go.